Hi. In this video, I'm going to complete the testing of this PCB. Recall that on these counter ICs here, I actually have them wired backwards for increment and decrement. But for loading, it appears that things are actually being loaded properly. So I want to confirm that that's actually the case. There's no additional problems and figure out if there's any more electrical issues that need to be solved on this. And then I want to introduce a CircuitVerse project that I have going in parallel. Let's get into it. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, I'm back here testing, trying to figure out the full extent of the troubles I have with this particular PCB to figure out what else I need to try to fix. So if I was to, on my input board, switch all of these dip switches up to on, load, and latch, you can see that all the lights come on. And I know those are bright. Yeah, I wish I had something that would dim that a little bit better for the camera. I may have to go for some higher resistors, higher value resistors on the next board. But if I turn around and turn all of these off and load and latch, everything turns off. And then if I go one bit at a time, load and latch, that's one light that's on. Second bit, load and latch. 3 bits, load and latch. 4 bits, load and latch. And continuing along here. And then when I get to this bit, watch what happens here with these two LEDs. So this one is off and this one is off. Load and latch, they both actually turn on. If I was to turn everything off and turn on the next bit up, load and latch, everything turns off, but you can see here that this bit should be on. If I turn that bit off and go back down one bit, the one that turned on too, you can see there are 2 lights that are actually on here. So I've got something that's cross-connected. If I continue to go up, or actually I'll start from the top and work my way down. Top bit is on. Add 1 bit next down. Add 1 more bit down. Everything works. Of course, the least significant bit in that nibble makes no change. So I've got to try to troubleshoot that. And I don't believe this problem is here. I can confirm that by bringing in my tester and set on continuity such that it'll beep for me. And I don't believe that these 2 pins are cross-connected, and they're not here. So that test there gets me here, and then it gets me at least to the counter ICs. So it could be a problem here with the, actually I don't remember which one's the most significant or least significant byte, but it could be with the actual latch itself. 1, 2, 3, 4, 5, and 6 on the top. So 1, 2, 3, 4, 5, and 6 on the top. And then 1, 2, 3, 4, 5, and 6 on the bottom. So that's the output. That should get me bound to this switch. Maybe I need to break out the microscope. Because there is a fault somewhere in here. So let me grab the microscope. So I'm looking at this LED here and that LED there, and they are not cross-connected. They are not shorted that I can tell, which means that there shouldn't be a short in this IC either down here. So that would be 1, 2, 3, 4. And not shorted. So then I should be able to look at 1, 2, 3, 4, and they're not shorted either. All right, so going back to my schematic, where else do I need to test this? Let's get rid of the front copper, the back. That's this area right through here. So 1, 2, 3, 4, and 5. It's pins 14 and 15. So let's go back and look at the correct pins. 11, 12, 13, 14, and 15. These two pins. Are inputs, and they're not cross-connected. Could I have a bad IC here? All right, let's go back. Let's trace that backwards. So, here we go. 5 pins from the left up. Let's see if we can zoom out. I can't zoom out. So this is unfortunately going to be partially viewed. So this pin should be directly connected down to 1, 2. No, it should be on this side. All right, so let's hook that back up again. And let's see the logic probe. So now with this setup again, I should have, based on this switch, this fourth light on. So do I have a good signal here? Let's try plugging in the power first, Adam. Okay, again, there we go, power. Do I have a CMOS? Yeah. Do I have a good signal here? So it's high. So I should have a good signal here, which is good. Now the question is, do I have a good signal here? So high, 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 and low. So I do not have a good signal here. So that's low. Tracing back here, I do not have a good signal there. Let's try this on camera. Back here, high, 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 low. Now up here, high, 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 floating. Floating input. All right, so if that's the case, that should be going to, let me go back and trace that. Desktop. So this one would be the one. That's the output. High, high, high. That's the one I want to look at. And that would go to the top, the second top counter chip. That's the second pin from the right on the bottom. So that would be pin 7. I think it's an 8-bit or 16 pin. So let's see here. That is high. So is that pin soldered properly? Let's take a look under the microscope and find out. Let's see here, which one? We were looking at this pin right here. That's moving as I touch it. As I push it laterally, that moves. Yep, that is a not good connection. All right, let's get the soldering iron warmed up here. Okay, I'm going to start with a cleaning. Right through there. Gonna need some solder to go with that. Actually, maybe I'll do this under the microscope and make that a little bit better. So looking here under the microscope, it is that pin right there that did not make a good connection. I think I may have a challenge with this one and that one. So let's just shore them all up. And then I want to spin this around and just double check each of these. Now remember, these were the first ICs I soldered on this board. Let's see here. It does look like a better electrical connection. All right, now we can give that a try again. Okay, and load. And so yeah, I've got all 4 of those set now, but I still have a cross connection somewhere. All right, let's see what happens if I plug all these control lines in, just to take that out of the mix here. No floating inputs. That's better. Okay, floating inputs. So that's just this pin or this bit right here. Oh man, it's all off camera. You don't want to do that. All right, so with that bit, this bit here set high, latch and load, that is correctly showing that 1 bit. If I switch to the other side, latch and load, that is correctly setting that 1 bit. And if I do both of them, latch and load, both bits are on. None of them, latch and load, blank. And that's perfect. So now I'm just going to run through this test one more time, just to make sure I didn't mess anything else up. Just turning each bit on in sequence. The bit in question. That all looks good. Now, it's dim. Why is it dim? Because I lost my ground. I lost my ground pin altogether. That's fun. See if I can get that to turn on. Good. So everything is on. Now, the next thing is I'm going to stick this into a breadboard. I'm going to take my outputs, plug them in here, and pulling this down towards me so that you can see the output. I'm going to connect these up here and connect these here. If I assert onto address bus 1, everything turns on. So let's reset the test again. Everything cleared down to zeros. Latch and load, so that's 0. And then I'm going to 1 bit at a time and check. That's the low order byte. Okay. And that's everything outputting properly. And then if I switch over to address bus 2, that's everything outputting as well. ALUA and ALUB, I'm going to assume are okay. I've actually tested that and all the lights turn on, so I believe I'm really good there. Now, in the time between the last video and this one, I did find this digital circuit modeling website called CircuitVerse. And I have gone out there and started a project to model my 16-bit computer in the CircuitVerse website, if you will. And of course, I've got to put a disclaimer out there. This is not intended yet to be a viable project, and therefore, if you invest any money in your own hardware, the risks are yours. But what I did do is I did model up the 16-bit register that I've been working with. And in order to do that, if I zoom in here, I had to model several of these ICs. So you can see 74HC138 modeled. You can see a 193 modeled. And some notes in here about what things that I've had to do. A 541 line driver, the 574 register. And you can see I've got in here a D flip-flop with set and reset. And that's what this circuit is, which have been repeated 8 times then for the register. And then I've got a set reset latch, which I've got modeled as well in the 193 chip. And then I've got the register test circuit, and it's modeled up, or doctored up, if you will, to be a program counter. And you can see how it counts and how it would count in real life. This is what I'm striving for at this point. So I will put a link to the project down in the description so that you can jump on here and feel free to fork it and play and have some fun with this. I will continue to update and add to this project on CircuitVerse as I continue to develop this out. Thank you. We'll see you soon.